Hey guys, welcome to Algos Made Simple. Today we've got Leetcode1TwoSum, and again our purpose is to do these problems as simple as possible, and we got a nice one today that's very simple, but it still gets asked in interviews, still comes up. I had a friend that actually got asked this in a Fidelity interview the other day, so definitely something you want to have in your tool belt, something easy to keep in your tool belt, and something that if you get asked this in an interview, you should be excited, you should feel like, hey, thank God, let's go, let's operate on this one. So diving into this one the same way we want to do it, like we would in an interview process. I'm going to read the question, then I'm going to repeat the question, and then I'm going to go through there the rest of our interview steps. So again, Leetcode1TwoSum. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Alright, so I would let the interviewer know. Alright, I understand I'm giving an array of numbers, and I'm trying to take two of them and add them up to the target that I've been given. And I can't use the same number twice, so if I had 4 as my target and I have a 2 in my subset, I can't use that 2 twice to make 4. I know there's only going to be one solution, and there is going to be a solution. And again, I can return the indices in any order. So look at the example here. We've got target equals 9, and we get this input array nums of 2, 7, 11, and 15. So conceptually, this is about as easy as it gets. You look here and you're like, okay, I need two numbers from this list equal 9, 2 and 7, done, bingo, let's get out of here kind of thing. And their indexes, index 0, the very first one, and index 1, number right beside it. It can't get simpler than that. So how would we do this in code? So if you've been coding for a minute, you should know that a lot of these problems, if not the majority, are going to utilize a for loop. And the simplest way that a lot of people attack this problem is to do double nested for loops. And what would happen there, that's going to be O of n squared, and you probably know where this is heading. You would take the 2, and then you go in the next for loop, and you'd have the 7. You'd add them together, see if they equal 9. If they don't, you do the 2 and the 11, the 2 and the 15. Eventually you go back up, you do the 7, and so on and so forth, adding all these different combinations, trying to see if you have something that equals 9. Well, that's fine. That'll probably be an okay thing to do in an interview, but it's really the optimal solution for this one is really pretty simple, and something that's even more condensed code and just kind of something that would be a little bit more impressive. And again, it's simple enough. Let's see what we can do here. So what we want to do, we've already gone through the example. It's nice to go ahead and get a game plan together. So for this one, what you're looking at to make this so easy is if you're familiar with a hash map, if we can spell today, if you're familiar with a hash map, which is basically just a dictionary in Python, what we want to do is as we go through these numbers, and it'll just take one loop through the array, we want to add them to a hash map. But while we're doing that, we want to go ahead and check and see if this target minus the number, so target minus 7, so 9 minus 7, see if that number is already in the hash map somewhere. And we can do that. The lookup is in O of 1, so what we'll do here is we know we need a hash map, and we know we're going to need at some point to see what the difference is between the target minus num. So that we know that's a variable we're going to be coding up. So that gives you two key components to this one already. So it's always good to have a game plan because one, it keeps you on track, but two, it shows the interviewer, okay, well, he knew he needed to have that in, and then if you end up, stumbling at some point, it at least shows that you had some idea what was going on. So we're just trying to get everything together for us, but also to showcase, hey, look what I'm doing. I'm keeping the conversation going. I've got some ideas. I know what a hash map is. So going with that, we're going to call our function toSum, and again, it takes nums and it takes a target. And what we'll do from there, we want that hash map we've been talking about. And normally, if you're doing any kind of pairs of something, or you're checking for a duplicate or whatever, it's not a bad idea to have a hash map. So if you're not familiar with them, that's something to look up. But a hash map basically is just key value pairs. It's just going to show you, it's just an easy way to look up. So after we do this, it'll probably make a lot more sense. If you don't know what one is, if you do know what one is, I'm sorry for wasting your time. But again, we're trying to make these as simple as possible. So I'm going prev map, just previous map. So what we've already gone through previously. I'm setting it equal to an empty dictionary here. And then what I'm going to do from there, I'm just going to do a for loop. Again, if you're struggling for where to start on a problem, you might want to write down a for loop, because you're probably going to do a for loop at some point and at least get something on the board, get you going. Like, you know, 99.999% of the time you're going to be utilizing a for loop. So let's go for I, comma, in enumerate nums. And if you haven't seen this before, all this is doing is you're taking your in, which is the number in nums, so the number in our array nums, but you're also at the same time indexing it. And what we could have done for in and nums and had an I here, set an I equals 0, and then done the I plus 1 each time through. That would have been a way you can do it. So if you're not as comfortable with the enumerator, you don't think you remember it, you could do something like this and get rid of that enumerate for in and nums and have up here I equals 0, and come down here, and each time we get through the loop at the end, so whatever we do in the loop here, then you do I plus equals 1. So again, in that I plus equals 1, you're just adding 1 to I there, over and over. So let's do it this way though. Let's try to keep it more condensed code. And again, don't have to do it this way. That's the way we're doing it. For I, comma, in enumerate nums, and all we're going to do here is, remember that difference variable we talked about, we're going to do difference equals target, which we're passing through up here, and we're going to do target minus in. Alright, and then once we have that difference, we know what's lacking. We have this in, whether it's 2, 7, 11, 15, whatever, we know what we need. So if we had a 15, the 9 minus 15, we need a negative 6 to be somewhere in this array. That's what we need to search for it. So how are we going to search for it? We're just going to do an if statement. If difference is in that previous map. So if we've already passed this difference at some point, then we know we got the solution here. So what we'll do is we'll return the index I, where we're iterating. So that happens to be the one we're on right now. That's the number we're on right now, index. And we're going to be able to take that, and we're going to take previous map, and we're going to take that difference, and that is going to give us the index that difference right there. If it's not in there, what we'll do here is we'll do previous map at this in, so at this number, and we want to put the index as what it's equal to. And the reason we do that, because we're going to be looking up a number, not an index on this, and we want it to return the index. So we want, when we go through here, we want to look up, if we're missing the 7, we want to look up a 7 here and see that the 7 corresponds, or see the 2 and see that the 2 corresponds with index 0. We don't want to look up 2 index and see what it corresponds to number-wise. That's not what we want. But anyway, this is very short, very simplistic code, but it's the optimal solution here, or it appears to be. It's O of n time, and it's a lot better than your O of n squared solution with the double nested for loops. And again, it's just as quick, just as condensed. So this is one to have in your tool belt, very easy. So let's go through and test it out just to make sure this works out. So we bring down this 2 in here. So we've got index 0 and we've got 2. The difference is the target minus n. We've got 9 minus 2. The difference is 7. Is difference in the previous map? It is not. So we'll come down here and do previous map at the number 2 is index 0. So your previous map is right here at that point, and it's got 2 and the index 0. So when we look up 2, it'll pull that 0. So that's all we have so far. We'll go to the 7 here, and we'll say, okay, we're at index 1 and 7. Target minus 9, so our 9 minus 7 is 2. Is 2 in the previous map? Yes, it is. So we're going to return this index 1, and return this previous map at the difference 2, so that's going to be 0. 1 and 0, we're returning 1 and 0. That's the solution. We're going to return it in any order, so that's what we've got. We're good to go there. So again, guys, very, very simple one to start off with. You need to have this on your tool belt, and you probably need to have it as the optimal solution. But if you get just really nervous and can't think of it, the double nested for loops are fine. But thanks for hanging out, guys. We're going to move on to the next problem and see what we can do from there.